Good morning and welcome to the EBA webinar, Understanding Digestate, Nutrient Cycle, Soil Quality and Energy Resilience. This is the second webinar of a series that is called Deep, providing details and perspective on biogases. My name is Giulia Cancian. I'm the Secretary General of the European Biogas Associations, and I will be this event moderator. So when we talk about biogases, often we think about the renewable energy carrier, biogas, which is the end product, and this is a bit of an incomplete vision. The anaerobic digestion is a circular process that offers some societal solutions, some very important ones, to challenges such as farming emissions, for example, and waste management. And this provides, of course, an energy carrier at the end of the process, but also importantly, co-products such as bio-CO2 and digestate. And digestate will be the subject of today's meeting, and we're going to talk about it. But we're also trying to understand how this can help substituting chemical fertilizers in agricultural practices, but also what are the environmental and safety standards that we need to respect to handle this material in an environmentally sound way. And we will touch also upon innovation, and we will see whether there are some challenges and barriers to its commercializations. We'll dig deep into regulation as well, and what are the boxes that we need to tick when we're thinking about having digestate as an added value product in our market. So in the next hour, you will hear from 4 different speakers. You see them on the screen at the moment. And they will be offering different perspectives around digestate utilization. So we will also use this webinar to officially launch the EBA white paper on digestate, exploring digestate's contribution to healthy soils. And in this occasion, I would also like to thank the authors for the work. First of all, Gabriella Papa, our project and technical officer, Miche De Corte, our technical manager, and Lucille Sever, as well as the EBA national associations and members who helped us out pulling together data and useful information. Today's program will start, as you see on the screen, with the regulation. So we will deep dive into the fertilizer product regulation, and this is actually a great instrument that is providing standards to commercialize recycled nutrients and digestate-based fertilizers. We'll see better how, thanks to Jeremy Pint that is here with us. Then we will leave the floor to Miche and Lucille to dive into the work of EBA on digestate from a technical and a regulatory viewpoint. And we will finally close with the experience from an FPR certification for biogas residues from Trust. So before we listen to our speaker, a couple of housekeeping notes. So more than 650 people registered to today's webinar, and we're now seeing that the participation list is getting larger and larger. So we welcome your questions, and we'll try our best to address them all during the Q&A session at the end of the webinar. Don't hesitate to post your questions during the presentations or to support other questions that are posted, liking them, should you be interested in hearing a reply. The slides of the webinar will be made available to participants after the webinar, together with the recording and with the white paper that we're launching today. So I am finally happy to welcome our guest speakers, Jeremy Pint, Policy Officer at the European Commission's DG GROW, and Ildiko Varga, Expert on Biostimulants on Trust. Welcome. But let me also introduce you to Miche De Corte, our technical director and co-author of our white paper, and Lucille Sever, EBA policy officer and our lead on circular economy and agricultural related files. So let me leave the floor to our first guest speaker, Jeremy Pint. Welcome. And we will hear from you on the fertilizer product regulation and how this can be interested for digestate-related products. Jeremy, the floor is yours. Thank you.
Good morning, and thanks, Julia. Thanks to all for being there and to EBA for the invitation. So it's my pleasure to walk you through the regulatory landscape for fertilizing products in the next 15 minutes. I've divided my presentation in two parts. One very short will be a brief summary of the regulation and the regulatory landscape. And then we will try to go around in a 360 degrees around the fertilizing product regulation and to see what are the links to other policies at EU level. So what is the fertilizing product regulation? It is linked to CE marking. And as you may know, it belongs to a wider approach in the Commission for various types of products called the new legislative framework. It sets harmonized rules on how product can be made available on the market. When a fertilizing product can be CE marked, it would benefit when placed on the market from the free movement in the single market. But be aware that in the case of fertilizing product and the fertilizing product regulation, it's optional harmonization. Be aware as well that the FPR, as we call it, is a product-based regulation. So it regulates only the placing on the market, the labeling, the conformity assessment, but it does not regulate the use of products or the mode of application. And it's quite recent piece of legislation. It's fully applicable since July 2 years ago. So when I say optional harmonization, it means that a manufacturer of a fertilizing product can choose whether he wants to place on the single market according to FPR, and that means their fertilizing product has to be CE marked, or those manufacturers can choose to go and place on the market on national markets according to national rules, and they may be different from the FPR rules. And then it's his or their product would hit one national market, and they can spread the marketing of their product via mutual recognition. So second concept, what is a fertilizing product, an EU fertilizing product with the CE mark? So a product has a function, one function. It cannot be multiple function, and there is guidance about it. You see that later. One function, but as many components as needed and as the manufacturer wants to formulate. So that is the product, and how the product can be CE marked is when the products comply with rules that are set for the components it contains, or the function it bears, or the function it bears. If the product is compliant, then it can benefit from the CE mark. The compliance is either drawn internally for some cases, but it also can derive from an assessment from a third party, but you will hear all about it with Ildiko presentation later on. So that was for the brief summary on the fertilizing product regulation and actually how to place fertilizing products on the market according to national rules. And now we are going to have a look at what's cooking, what has been done so far, and what could be the future on various sides of the fertilizing product regulation. So first, on the components that are allowed to be part of an EU fertilizing products. So you've seen on the previous picture that we have various categories for component material, and we try to populate them as much as industry needs it. When we have as well a safety assessment that a new component material is safe to be used in an EU fertilizing product. So you have various types of component material appearing on the slide, animal byproducts, industrial byproduct, high purity material. All those component material were assessed and developed, and you see that the progress bar that I personally put on or in front of some component material shows how developed the issue is. What I would like to raise to your attention is the last two bullet points on this slide, the technical study on new component material that goes together with an ongoing EU survey. So we know that there are component material which are interesting and relevant for industry, and we have permanent ongoing EU survey for industry to inform the Commission which component material they would like to use. From time to time, we take stock, we take a snapshot of the EU survey, and we prioritize and rank the suggestion. Some of them we would run a technical study with the help of consultants to assess the safety and the agricultural relevance as new component material. So one question maybe something I wanted to make you think of is for some animal byproducts from some CMCs like animal byproducts, DG GROW is not the sole service of the EU to have a look and assess the safety for AVPs. For example, we can only take advantage of an EFSA opinion on an endpoint to be set for animal byproducts. So how does this comes into the real life? So for example, we have adopted a delegated regulation to include process manual in component material category number 10. We have as well developed a draft regulation on biodegradability criteria for certain polymer. And under point A, this might be relevant for some polymers that may be used as post-processing in the case of digestion. And then we have other technical amendments that try to adapt to the technical progress and available knowledge and science, FPR. So you see the draft delegated act with the two arrows, the two blue arrows on the left. They are draft and they are up for consultation. So if you have insight, you want to provide feedback, please do so before the 5th of April. And now coming to looking into the future. So we have now at the time being 3 studies ongoing, and some are maybe relevant for digestion. And that's the first and the third study. So if you want to know more, you have the email to contact the project leader in the contractant that is working with us. Feel free to do so, or feel free to contact us at DG GROW. The second thing I wanted to make you aware, but very quickly, is another initiative, and it's more about labeling and how labeling for EU fertilizing products can be made digital, partially or totally. In short, and you have the link if you want to have the full provisions, the digital labeling is not mandatory. It's possible to go for digital label only for specific products or specific cases, but in that case, a label should be provided at the point of sale. And there are cross-cutting general provisions that are to be set up. So digital labels for fertilizing products, but also for other chemicals could be aligned, and we don't have specific rules that are diverging from one sector to the next one. The next point I wanted to touch today, but very briefly, it's about economics. And in the course of the current situation with a difficult situation for fertilizers on the EU market, the Commission has issued a communication, and there are some follow-up action ongoing. And I don't know whether from EBA there are from that communication on making the fertilizing product market seamless and smooth, well functioning, if there are any action as well from EBA. The next point I wanted to touch upon is R&D, because if we want to have a more circular market and circular economy for fertilizing products, I guess there is new products, new component material, new technologies to be developed from lab and scaled up to industry level. And for that, we have instruments like the Horizon Europe program. And that call is now finalized, and we have ongoing dossiers or even ongoing projects. And aside this, very recently, the Commission has adopted a communication on biotech and biomanufacturing, and that could also be part of the landscape or the strategy of the biogas sector to consider how you could use the strategy developed by the Commission when it comes to biomanufacturing, for example. And you may have, or you may be involved either as EBA or as a member or just somebody involved in biogas with those projects. So if you need, please reach out to us and we can maybe liaise, or that will be as well good to be informed of projects in the area of digestion. The next one is standardization. So standardization and standards, including harmonized standards, is a way for a manufacturer to demonstrate that their product complies with the rules and could be CE marked. So we have several projects ongoing when it comes to standardization, and we have we have made in the past, and we still have a standardization request running with SEN, the European standardization body, and we try to cover for each requirement and rules when in the fertilizing product regulation. We try to cover that with a appropriate standard that is developed or that is adapted from an existing one to be fit for purpose. So from the previous requests in April 2022, what we expected as technical specification were already published, and we are in the process of turning some of them into harmonized standards, and that will be for plant biostimulants. The equivalent transformation of technical specification into harmonized standards would be, the next batch would be for July 2027, and that would cover soil improvers and fertilizers, and that would be maybe more relevant for digestate. In parallel, as we have modified and we have updated FPR, we have introduced new rules for new CMCs. So we have issued a new, we would issue a new standardization request to cover the additional requirements. But SEN is quite busy, so this will take time, and but hopefully in the end we would have all the rules in FPR covered by an appropriate standard. So on another side, but it's still linked to how to assess a fertilizing product, to draw up the technical documentation and to inform, justify that if an EU fertilizing product rightfully bears the CE mark. And so it goes through, part of the process is building the technical documentation for an EU fertilizing product. And we know it's a complex step of the process, especially for SMEs. So we have contracted out a study to bring some guidance and offer this to stakeholders for them to have an easier way on the technical documentation. So the last points I wanted to make is about communication. We have different fora, and you may be aware of them. Most of the stuff discussed there, especially the expert group, is publicly available. And we have quite a lot of other initiatives that are related to FPR, but we're going to maybe touch that upon the Q&A, as I'm kind of running out of time to dive into more details there. I would like maybe now to jump to one step that is upcoming. We have a review clause in FPR, so we are going to have a full evaluation of this legislation, and that would be for somewhere in 2025. We have to finish the exercise by July 2026. And last but not least, if you want to know more, this is the list of available resources publicly available that you can consult. If you don't find what you are the answer you're looking for, you have the functional mailbox to reach out to the fertilizing product team in DigiGrow, and feel free to do so. We will support you. Thank you, and I look forward to any question you may have.
Thank you very much, Jeremy. And I think that we can safely pass also to our second speaker. But before that, thanks a lot for a very comprehensive presentation touching upon standards, current activities, and strategies of the European Commission stimulating, for example, biotechnologies, which are also covering partially the work under the Digestate, the fields of application of the fertilizer product regulation, but also the possibilities to contribute and give an input to the policy design part. We will come back to that. I see that you already have a couple of questions for Jeremy, and I will be happy to pose them to you in the Q&A session. But now we'll go also to the heart of this webinar today with Mieke de Korte. Mieke, please tell us more about the white paper that will be published today. Mieke, the floor is yours.
Thank you, Julia, for the introduction. From my side, I will talk a bit more on the technical perspective towards Digestate and explain a bit more what is Digestate exactly and what is happening in a biogas reactor that makes Digestate so interesting and valuable, and also to talk a bit about Digestate applications that we have. So first of all, the very basics is, so during the anaerobic digestion process, biogas is produced, but as an additional product, we also have Digestate. So why is Digestate such an interesting product? So during the AD process, part of the organics are transferred to biogas, but a big part of the organic materials also are returned or stay within the Digestate, basically. And then, because biogas consists of methane and carbon dioxide, this means that the nutrients, so the mineral fraction of the raw materials, they actually stay in the Digestate, which makes it an interesting fertilizer. So to go a bit more in depth, what exactly happens in the biogas reactor? Okay. So starting from the raw feedstocks, so the raw feedstocks exist for a very big part of biodegradable organic matter, then for a smaller part of poorly degradable or stable organic matter, and then also for a part of nutrients. So the biodegradable organic matter, 2/3 of this is transferred into biogas thanks to the microorganism in the reactor, and the biogas consists of methane and carbon dioxide. Then when you look towards the poorly degradable or the stable organic fraction, this is largely maintained. And this means that the stable organic fraction in the digestates is approximately the same as that what we have in the raw feedstocks. Then when we look towards the nutrients, it's the same because in biogas, there is no return of minerals. So this means that the nutrients such as nitrogen, potassium, and phosphorus, they largely stay within the digestate. We also have then an additional fraction of organic matter in digestates, which is the living organic matter. And these are basically the microorganisms which grow and which were fed by which were feeding on the raw materials in the digester. So this living organic matter actually grows during the anaerobic digestion. So as a result, the digestate contains 3 forms of organic matter. It's the poorly degradable or the stable fraction of organic matter. This consists mainly of lignin and celluloses, and this is a very important property and a benefit of digestate because this is a precursor of humus material. And it's improving the clay-humus complex of the soils, and this has many benefits. So when you have more humus in your soil, you also have better water retention, better nutrient retention, and also in general, it improves the structure of your soils. Then second, we have the biodegradable fraction. So although a big part is transferred into biogas, there is still around 1/3 that stays within the digestate. And this consists of soluble sugars and hemicelluloses, for example. It's also, let's say, an interesting fraction because this provides energy and nutrients for soil bacteria. So with this, it improves also the microbial activities within the soil. Then thirdly, we have the living organic matter. So these are basically the microorganisms which grew during the anaerobic digestion process. And they also provide benefits because they can transform organic elements into mineral elements. So this means specific nutrients which are bounded to organic matter in the soil. They can be transferred towards minerals that are accessible to plants. So apart from the organic matter, we also have the nutrients, and the nutrients, they are preserved during digestion. So biogas is, as we also mentioned in the previous infographic, it's composed of methane and carbon dioxide, which means that fertilizing elements, nitrogen, phosphorus, and potassium, they are preserved. However, although the volumes are the same, some elements are transformed during anaerobic digestion towards the benefit of plant growth. For example, the organically bound nitrogen in the substrates is partly mineralized. So this means that the organic nitrogen is transferred into ammonium and also nitrates, and these are better accessible for plant growth compared to the organic bounded nitrogen. So this really makes a difference between, a very important difference between digestate and its raw materials. Then moving further towards different types of digestate. So we talk about raw digestate or whole digestate as the direct output from digesters. And in some cases, or in many cases, it can be chosen to from this raw digestate to execute a phase separation. So this means that we would separate the raw digestate into a liquid and a solid fraction. The reason can be for further processing or for better handling of the digestate. For example, the solid fraction after separation of raw digestate is much more it's a much better product to transport over longer distances, for example, than the raw digestate. So the nutrients are not distributed equally between the liquid and the solid fractions. It's very well known that, for example, the nitrogen goes largely to the liquid fraction, whereas the organically bound nitrogen goes to the solid fraction. For the potassium, it's a bit more distributed. It can go to the liquid and the solid fraction. And for the potassium, in general, we assume most of the potassium to go also to the solid fraction. Then when it comes to the fibrous materials, this is almost completely goes to the solid digestate. And then when we talk about the volumes, the biggest part of the volume will return in the liquid digestate, whereas the solid digestate will have a lesser part of the volume, which also makes it interesting to transport indeed over longer distances. So in terms of use, the liquid digestate is very suitable as a fertilizer and to be used in the direct, let's say in the direct environment of nearby farms near a digester, whereas the solid digestate is often used as an amendment to improve the structure of the soil. So when we apply digestate, as with every fertilizer, it's important to do this in a sustainable manner and to apply sustainable agronomic practices, mainly also to avoid nitrate leaching when you do digestate application. So it's well known how to do that. So digestate application must be adjusted to specific time periods and growth states on the field. So you basically need to adjust your digestate application towards the needs of the plants that you are growing. This is true for every fertilizer. For digestate specifically, some attention should go also to the organic nitrogen. Because this organic nitrogen in general, it's a benefit for plant growth, but we also need to consider that this continues to mineralize over time and it should be controlled. For example, this means when at a later point in time you add additional fertilizers or additional digestate, you need to consider that there is already some nitrogen in the form of organics in your soils. Then last but not least, digestate application can also be coupled with catch crops who are able to retain the nitrogen and other nutrients in your soil. So on the next infographic, we have now talked a lot about the application of digestate in agriculture, but beyond that, and as also already mentioned by Jeremy, there is a lot of R&D ongoing towards novel digestate applications, and a lot of this R&D it's actually done under the Horizon Europe program. And this infographic is summarizing the TRL levels of different novel digestate application routes. I will not talk about all of them in detail, but for example, the cultivation of insects, it's already very well tested. This can be done, insects can be grown on the solid fraction of digestate and it's working well. Digestate can also be used as a biostimulant or for example, as a pretreatment agent. And this means that digestate is actually very well suited to pretreat harder to digest feedstocks, which have a higher content of lignin and celluloses, for example. And you will see that with using digestate as a pretreatment agent, these feedstocks can become more digestible. Also, the growth of microalgae on digestate and specifically on the liquid fraction has also been intensively tested with good results. So moving further, we have or to investigate the impact on the environment of anaerobic digestion and digestate, we have compared the environment impact in different sections between anaerobic digestion, composting, incineration, landfill, and no treatment as organic waste and byproduct management practices. And you can see that when we look towards anaerobic digestion, it ticks many boxes. We can have energy recovery using the biogas. We also have nutrient recycling, contribution to soil health because we can improve with the stable organic fraction, the humus in the soils. We also have other reduction and sanitation properties. When we compare it, for example, with composting will also have a lot of good properties. It will also contribute to soil health, other reduction, and it has sanitation properties. But we see, for example, that there is no energy recovery, and also the nutrients recycling are more limited when we compare it to anaerobic digestion. then when you look towards positive impact on the climate, and then we specifically look towards reduction in greenhouse gas emissions, there are different ways on how Digestate is reducing greenhouse gas emissions. First of all, we have avoided methane emissions when organic materials go to anaerobic digestion, because when organic materials are not treated, they let's say natural occurring methane emissions can happen, whereas if you bring this to an anaerobic digestion plant, those methane emissions are avoided. But also the replacement or the reduction in the use of synthetic fertilizers is important, because you avoid the emissions that are related to the production of these synthetic fertilizers. And thirdly, also the building up of soil organic carbon, because when we apply Digestate, and specifically the solid fraction, we can increase the humus in the soil, and with this we also increase the storage of carbon within our soils. And lastly, we also have that usually Digestate transport routes are shortened compared to other fertilizers. Moving to the positive impact on soils, it has already returned in different parts of this presentation, but the stable organic fraction of Digestate is enriching the humus content of the soil, and humus formation in the soils is critically important because it has many benefits, and they are listed here. So we have improved nutrient retention, also improved water retention, and a general improvement of the structure of the soil. Humus also has a pH buffering properties. It improves the microbial habitat, so the microbial activities of the soil can benefit from this, and we also have carbon sequestration properties. And this, I will close my presentation here and ready for any questions in the Q&A.
Thanks a lot, Mieke. That was a very comprehensive presentation, touching upon the basics, but also giving the idea of what are the sustainable agronomic practices that should become the standard in the future. And this is actually a very timely conversation that we're having, because we consider that 60–70% of European soils at the moment are in bad conditions. And we also need at the same time to cut on chemical fertilizers use. So great also to see that there are innovations in the pipeline, and that should also become the standards for the future. But now we will pass to the regulatory side with Lucille, and we will check whether everything is working fine, whether all Europe is reacting in the same way, or countries are deciding to put different standards. So Lucille, thanks a lot, and the floor is yours.
Thank you, Julia. Good morning, everyone. So now, what did we include in the regulatory part of the paper? So the first section of the regulatory part of the paper is an overview, actually, of the EU legislation governing the production, application, and marketing of Digestate. I will not enter into too much details, but at EU level, we have first the Waste Framework Directive 2008-98, which, as you know, is setting a basic waste management principle. But this directive is also actually encouraging member states to take measures to set what we call an end-of-waste criteria. So when a waste reaches that end-of-waste criteria, by being compliant with a set of requirements, it is no longer considered waste, but a product. So it is based on the Waste Framework Directive that member states can decide to set an end-of-waste criteria for Digestate from waste at national level. But we will see later that the implementation of this criteria differs largely between member states. Then we have the Fertilizing Products Regulation 2019-1009. As it was already explained, it establishes harmonized rules for the placing of fertilizing products on the EU market, including fertilizing products derived from Digestate. So Jeremy already introduced the FPR, and Ildiko will also give more information on the functioning of the regulation in her presentation just after. So I will not enter into more details. But then we have the Animal Byproducts Regulation 1069/2009, which is also complemented by the Regulation 142/2011. So these regulations are actually setting rules for biogas plants processing animal byproducts. So for instance, the standard transformation parameter is 1 hour at 70 degrees with particle no larger than 12 millimeter, even if, as you know, competent authorities at national level can also authorize the use of alternative parameters. And more recently, also the delegated regulation 2023-1605 provided actually an endpoint for digestate from animal byproducts to be utilized as component material category under the fertilizing products regulation. So what does it mean, endpoint? It means that when an animal byproduct reaches the endpoint by, again, being compliant with the set of requirements, it is no longer subject to the animal byproducts regulation requirements. Then we have the Nitrates Directive 91/676, which requires member states to set specific measures aimed at reducing nitrates pollution in so-called nitrates vulnerable zones. And because processed manure, so including digestate from manure, is considered manure, it needs also to respect the low limit of 170 kilograms of nitrogen per hectare per year, whereas synthetic fertilizers can be used above this limit to reach the nitrogen requirement for each specific crop. And finally, we have also the Sewage Sludge Directive 86/278, which is setting additional requirements for the application of sludge, and also encouraging member states to adopt a national end-of-waste criteria for treated sludge, including digestate from sewage sludge. So we have one regulation that is only optional, and 3 directives. So as you can imagine, it can lead to divergences in the national implementation. And now I will tell you about the second section of the regulatory part of the white paper, which is focused on the national level. So our analysis delved into the legislative framework surrounding digestate across 20 EU countries, with the primary focus on national regulation regarding fertilizers and the implementation of the Nitrates Directive. So we achieved this by conducting interviews with National Biogas Association or leading biogas companies in these 20 countries. So by the way, I really want to thank again all the experts that participated in these interviews. Their contributions were essential. And so EBA member will soon have access to this 30 pages country analysis of the regulatory framework. And in the white paper itself, you will find this table that you can see on the left-hand side, which is basically summarizing key aspects for each country, including, for instance, whether digestate is included into a national legislation on fertilizers. This is also to be seen on the right-hand side in this map. So in dark green, for instance, you see the countries where digestate is included in the national legislation on fertilizers. In light green, it is not. But also coming back to this table, you will be able to check if digestate from waste can receive end-of-waste status under national law. And also in the last column, any additional interesting feature of the national legislation on digestate. And we've identified several crucial findings from these interviews, and I'll now dive into them with a bit more details. So firstly, on the local digestate market, what we found out is that raw digestate, so digestate has a low or no value in general. Raw digestate is very rarely sold, but rather freely supplied to farmers. Often the digestate producer will also have to pay for the transport and spreading. And in the best case scenario, it is traded against input material. And this is really everywhere in all the countries that we have interviewed. It can change a bit when digestate, for instance, is post-processed into pellets, but we don't have much information on this. In countries where there are more issues with poor water quality, eutrophication, groundwater pollution, and where also these issues are under higher scrutiny by citizens and governments, for instance, in Belgium, in Flanders, or in the Netherlands, or in Spain. In those countries, digestate use is more tightly regulated as part, for instance, of the nitrates action programs based on the nitrates directive. So, for instance, you will have longer period where you cannot apply digestate, and this can lead to potential challenges in digestate management. So we discovered that in such cases, biogas producers are obviously more compelled to seek regulatory and technical solutions to better recognize the benefits of digestate. So digestate might need also to be more post-processed in order to also export it to other countries. And another crucial factor influencing the digestate market is, of course, the connection of biogas plants to the soil. So we generally see two models. Either we have industrial biogas plants lacking land that need to rely on collaboration with nearby farmers, or we have on-farm biogas where the biogas plant and the use of digestate is really integrated into agricultural operation. So then, drawing from our analysis across 20 countries, we've synthesized a summary outlining the general feature of national regulatory frameworks for digestate. So while recognizing that there may be exceptions within each country's frameworks, this summary provides really a general overview of the regulatory landscape. So you have generally two different sets of rules. So first you have digestate from waste feedstocks. So it's already what is included in waste feedstock can differ a bit. It can be bio-waste, industrial waste, agricultural residues. And then you have generally three options. So the first one is that digestate receives end-of-waste status through national fertilizers law. So this is the case in Croatia, Czechia, Estonia, Poland, Slovakia, Spain, or through another legislation like in Flanders, France, or Italy. So this is normally the best case scenario, to have digestate being included in the national legislation on fertilizer and receiving the end-of-waste status. But what we actually saw is that it can still lead to some administrative burden if the legislation is not clear, or if it is lacking some provisions, or the requirements are impossible to meet. This is the case, for instance, in Spain, where you have this royal decree on fertilizers, which is setting minimum quality requirements that are actually impossible to meet for digestate. In Croatia also, for instance, liquid fertilizer is not included in the law, so that it might be impossible eventually to apply it. Then the second option is to have digestate included in the national legislation as a fertilizing product under national law. So it's the case in Austria, Finland, Germany, Greece, the Netherlands, or certified as a product through certification, like it is the case in Sweden, even without an end-of-waste criteria. And so in this case, even without being granted end-of-waste criteria, the effect can actually be similar to having an end-of-waste status. So for instance, in Germany, digestate from bio-waste and animal byproducts other than manure are categorized, as organic fertilizers and regulated by the Fertilizers Ordinance, but they still remain under waste legislation. And still, it is working very well, actually, in Germany. The third option that we have is that digestate is designated as waste, so not included in national legislation on fertilizers, and there is no end of waste criteria. It is the case in Hungary, Ireland, Latvia, Portugal, Wallonia. And their producer will have, for instance, to obtain a specific authorization or certificate of use to apply their digestate, or they will have to respect a spreading plan that will need to be frequently updated. So this typically entails a high administrative burden, and it will be particularly complicated when adapting, for instance, to a change in feedstocks. And then we have also digestate from animal byproducts. We have, again, three options. So the digestate can have animal byproduct status and be categorized as fertilizer under national law or certified as a product through a certification. This is the case in most countries. Croatia, Czechia, Finland, Germany, Greece, Italy, the Netherlands, Poland, Slovakia, Spain, Sweden. Or we can have digestate from animal byproduct, which is actually considered waste, but can be classified as fertilizers when compliant with certain requirements. This is the case in Austria and France. So, for instance, in France, the vast majority of digestate are dealt with a spreading plan under waste status. And this plan is also necessary for digestate from animal byproducts, but they can still obtain product status by complying with what we call digestate specifications. And the third option, finally, is digestate from animal byproduct that is treated as waste because of a lack of legislation. And this is the case in Hungary, Ireland, Latvia, Portugal, and Wallonia. So digestate from animal byproducts face similar restriction, actually, than digestate originating from waste. So in those countries, as I was saying, digestate is not included in a fertilizers legislation. There is no end of waste criteria. And in addition, it will also be complicated even for digestate from animal byproducts. So based on this analysis, we have two key takeaways. The first one is that it is crucial to set a clear legislation on fertilizers at national level, providing legal certainty for all types of products, including digestate-derived products from waste and from animal byproduct. And it's also important to provide requirements that can be easily operationalized and avoid red tape in general. And what we discovered also talking with the expert is that providing a net of waste status for digestates is actually only secondary because even when no longer waste, digestate can suffer barriers. And conversely, while still being under waste status, the market for digestate can be operational. But it does have an impact on the public perception of digestate. So as long as digestate is classified as waste, its value is diminished, hindering its broader acceptance and utilization. And finally, I wanted to present also some key challenges that we have identified for a wider use of digestate. So during the interviews, the primary regulatory barriers that was highlighted by respondents were the nitrates directive limits, which restrict the application of digestate from manure in nitrates vulnerable zones. So for many stakeholders, the authorization of renewal product from 170 kilograms of nitrogen per hectare per year to nitrogen requirement for each crop would be a first step actually towards creating a level playing field between organic and synthetic fertilizers. Then the lack of fertilizer status for digestate in national law is also a major barrier, as I was already explaining, as it leads to a restricted use of digestate or at least a depreciation of its value. And then, in general, the complexity of the regulatory framework for digestate, especially when farmers are the digestate producers, is an issue. So when you have industrial biogas, it's easier to have someone dedicated entirely to compliance with regulation, but it is not necessarily the case for farmers. So to conclude, stakeholders agree that the value of digestate as an organic fertilizer and soil improver is not sufficiently acknowledged and rewarded. So regulatory drivers are crucial to promote the adoption of digestate in agriculture. It could be in the common agricultural policy, in the taxonomy, or other pieces of legislation. And to conclude, I would say that we hope that this white paper will be useful for those interested in navigating the complexities of digestate regulation within the European Union. Thank you.
So thank you, Lucille, for being able also to summarize such a complexity in 10 minutes of different challenges, but also different opportunities that digestate-related products are having at the moment. I see an avalanche of hearts and claps online. So I hope that this presentation was indeed very useful for our members and the rest of the participants. Just before we pass to our next guest speaker, Ildiko Varga, an acknowledgement and a reminder. The acknowledgement is that we would like also to thank the Fair Play project to which we are part of. The Fair Play project is basically working to protect ecosystem and decrease EU dependence on fertilizers. And through also the network of our project, it was possible to us to invest time and increase our network of experts to come up with a solid analysis on the regulatory challenges and opportunities on fertilizer. The reminder is that, as Lucille touched upon before, we have included a summary of all the different drivers and the analysis that Lucille has brought about in the white paper. However, 30 pages in-depth analysis of the different legislation in the different countries analyzed will be available for our members, together with an interactive map in our EBA policy dashboard. This will also be made available to policymakers afterwards. And now we pass to our last speaker. So we will hear experience with the FBR certification for biogas co-products and residues with Ildiko Varga. Ildiko, welcome to our webinar today. You're an expert of biostimulants with Fertilizer, and I will give you the floor.
Thank you. Thank you for the kind presentation, Julia, and thank you for introducing me for this event. My name is Ildiko, and I'm working for an expert, as a biostimulant expert for Fertilizer. The reason why I'm here today, because I would like to make a short presentation regarding biogas certification procedure. However, the problem is that I cannot control my slides. Okay, thank you. So the reason why I'm here today after this short problem, that I have high experience regarding the FBR certification procedure in case of biogas residues. And during my presentation, I would like to give you a short insight, and I would like to talk about the most important topics of CE marking. First of all, I would like to give you a legal definition, what is an EU fertilizer, and I also would like to give a definition of a product function category, as well as the component material category. I also would like to highlight digestate into which CMC category could fit, and I also would like to give a definition of CMC 5, and I would like to talk about the input materials which can be used for CMC 5, the biogas residue. After this topic, I would like to talk about which module can be used for the evaluation and for the certification procedure. And last but not least, I would like also to talk regarding the technical documentation. So those documents which has to be applied by the manufacturers, especially on the label, because it's quite an important information. So let's just dive in. What is a new fertilizer? Only those kind of fertilizers, so those kind of products can be named as an EU fertilizer, which are in compliance with the EU regulation. Jeremy already told us this is the so-called FPR. This regulation gives us so many requirements and so many definitions, not only analytical definition, but also it gives the definition of the PFC. But what is a PFC? Manufacturers has to choose at least one product function to their EU fertilizer, and this function can be chosen from the product function categories. It is also mandatory to choose a component material category to all your component from the EU fertilizer. I give you here an example. For example, if you have a digestate residue, a biogas residue, you shall choose the category of CMC5. And after that, manufacturer also have to choose a PFC, so product function category, and many manufacturers choose the PFC 3E, which is the organic soil improver category. Naturally, there are many other categories for product function. You can choose other, but our experience is that so many manufacturers choose this. And how can a biogas residue put on the market according to this EU fertilizer regulation? It is mandatory to involve a notified body for the certification procedure, and after the successful certification procedure, you can sell your product as an EU fertilizer. What kind of input material can be used for a biogas residue and biogas making if you would like to sell it as an EU fertilizer? So first of all, the most important input material can be different biological originated materials, for example, separated collected biowaste, different kind of organic matters, for example, plant tissue, and any livable organic, which was usually lived. It is also possible to add different kind of additives to the biogas making, but it's also mandatory not exceed the 5% in this procedure. Lucille already talked about the animal byproducts and the possible input materials, and I would like to confirm that category 2 and category 3 materials from animal byproduct can be used as an input material of biogas making. However, this kind of material has to reach the end point from the animal byproduct regulation, and after then you can apply the fertilizer regulation. It seems a little bit tricky, but these are only hygienic requirements. And after the manufacturer fulfill this kind of hygienic requirements, the biogas procedure will automatically continue and the product can be marketed as an EU fertilizer. How can we evaluate the EU fertilizer? Since biogas is the so-called special CMC, it has to put into the CMC5. Based on the EU regulation, it is mandatory to apply the module D1 quality assurance system check, which is quite special because during the procedure, not only the technical documentation, but also the quality management system of the manufacturing will also check. It is quite a huge work because the manufacturer has so many things to do. First of all, they have to build up a quality management system. I would like to highlight that it is not mandatory to build up an ISO 9001 system. However, it is strictly requirement to build in the requirements of the fertilizer product regulation, which is well written in the regulation. For example, it's mandatory to make education to the coworkers. Manufacturer has to follow analytical criteria, and constant monitoring is also an important aspect of the fertilizer product regulation. And besides the quality management system, it is also essential to draw up a technical documentation. This is the moment when I would like to highlight the importance of the label, because the label is that kind of information with which the final user, the farmer, will meet first. And this is the information with which the market surveillance will check at the first time. So this is the reason why we think label is quite a key element of the technical documentation. How many audits will be needed for this quality assurance check during the 3-year-long certification period? So during the first year, we visit the factory first. This is the so-called initial audit. And in the end of the year, we also make a surveillance audit. During the second and the third year, we make only a surveillance audit. However, during this 3-year-long period, we will also make the so-called sampling audits. I already mentioned that CMC5 is a special CMC. This is the reason why it is mandatory for notified bodies to make these sampling mini audits. And during these audits, we have to collect samples to check whether the quality of the final product and the quality of the output of the CMC sufficient for the producing or not. I was talking so many information regarding the quality management system, and this is the time when I would like to talk about the technical documentation, especially the label. On the slide, you are seeing a general label from the labeling requirement documentation. I would like to give a couple of information regarding the points. So if you have a new fertilizer and if you succeed the certification procedure, you have to put the CE mark on the product. But since CMC5, so digestate residue, is a special CMC, we have to evaluate according to module D1. And this module D1 will belong right next to the CE mark because the identification number of the notified body must be given. I already mentioned that the manufacturer has to choose a product function category. That's the reason, because it has to be on it. And it's also mandatory to give different kind of nutrient content of the product. I already told that PFC3 is the most common chosen product function category, so I give the requirements of this category. It's mandatory to give the nitrogen, the phosphorus, and the potassium content when it is higher than 0.5%, but it is also mandatory to give the organic nitrogen content as well, and it's mandatory to give the origin of this organic nitrogen. And the reason is that if you are using different kind of animal byproduct input or manure input, you have to give this on the label, which could be a help for the farmers because they have to follow the nitrate directive. So this is the connection point between the FPR and the nitrate directive. It is also mandatory to give the list of ingredients. And if you are using different animal byproduct inputs or manure, you can also give the origin and name of the animal byproduct as well. Naturally, it is also important to give the instruction for use, the recommended storage condition, as well as information of safety, but manufacturer can also add different kind of other information, but this kind of information has to be validated as well. For example, if your product has organic farming certification, you can adhere into this other information session as well. I also highlighted the production date as well as the expire date. If you have the PFC3 category product, you doesn't have to give the expire date. However, if you have a biostimulant containing a biogas residue, you have to give the expiry as well. And I would like to highlight again these contact details. So the contact details are essential on the label, but the legal manufacturer's contact detail has to be given on the label. And I highlighted the importance of Chapter 2 from the regulation. So if the manufacturers would like to know what kind of requirements do they have, my suggestion is to read this Chapter 2 because it's quite an important part of the regulation. So how it is working in practice, how can we certify a biogas residue or a biogas plant? First of all, we are having a contract with the manufacturers. After them, they are sending us the technical documentation containing the label and other information, as well as the main documentation of their quality management system. We are also sending them an audit questionnaire, and after they are filling it in, we are visiting the site and making the initial audit. If we are finding any non-conformities, the manufacturer has to have corrective actions, and after then, they could get the certificate, which will be valid for 3 years. During this 3 years period, we are also making surveillance audit in the end of each year, and because we are talking about biogas, we also have to make constant control with mini audits, and this mini audits aiming the sampling, and the sample has to contribute the requirements of the fertilizer regulation. So in the beginning, the whole situation regarding the registration according to FPR and putting a biogas or a digestate to the market, a digestate residue, could be a little bit complicated and tricky, but notified bodies are helping a lot to the manufacturers. And after this slide, I think you could get enough help and understand how the whole procedure is working. Besides that, I also collected a couple of useful tips and links to you if you would like to start the procedure. My suggestion is to read at least the chapter 2 because it highlights the obligation of the economical operators. I suggest to read the requirements of the technical documentation assembling, as well as the requirements of the quality management system. I highlighted here the delegated regulation of endpoint determination of animal byproducts and other health rules for animal byproducts as well. After you are having a new fertilizer, manufacturer has to draw up a declaration of conformity, but you can find an example of the regulation as well. And I give here the labeling guidance, which can be quite useful and helpful if you would like to apply for the whole procedure. I collected a couple of links like the fertilizer regulation, the endpoint regulation, the health rules regulation, as well as the labeling guidance. And there is a frequently asked question document as well for the FBR. So if you remind any open question, you could get only ideas from this document, but you can send me a question to my email, or you can add any kind of question to the chat box or the question and answer session. So thank you for your attention, and I hope I could help and contribute to your work.
Thank you very much. Indeed, it was really good and refreshing to hear how you explained and you basically translated European regulation into quality management, certification, field audits, but also labeling. So what kind of technical information and transparency. I think it's fantastic to have also hands-on tips for companies that are getting started with this process and might feel a little bit lost when it comes to the complexity of the requirements. So thank you for that. I think that we are all set for an interesting Q&A session. Thanks a lot to the participants who were extremely active in the Q&A chat box. I see that also Jeremy has started in answering in written to some of the comments, but I will start with a warm-up question to Mike. I see here that one of the questions that is being asked is about carbon, which is quite an important element on which we're talking about a lot today. So do we know what happens to the carbon from the digestate when deposited in the soil? Will it be oxidized to CO2, stabilized, retained in the soil, or potentially even lead to possible emissions?
Okay, thank you. Thank you for the question. So you have two types of carbon in the digestate. Julia. Sorry. We have two types of carbon in digestate. So we have the stable organic fraction, which will bind with with the soil and which will increase the humus content. So it will basically stay within the soil and contribute to carbon sequestration. And then we also have the biodegradable organic fraction. And this is the one indeed that can be further digested and can be converted into carbon dioxide. But the interesting part about anaerobic digestion is that a lot of this process has already happened in the biogas reactor. So a lot of this conversion to methane and carbon dioxide is exactly what the biogas process is already doing. So it's captured and it's utilized in the form of energy. So the amount of emissions that can be produced when applying digestate is much less than when we apply the raw feedstocks or the raw biomass instead.
All right, thank you, Mike. So I will have another question for you right away, just to stay on topic. So what is currently the most applied end use of digestate in Europe?
Currently, in many areas of Europe, the most applied end use of digestate, it's as a fertilizer, as an organic fertilizer, but also as a soil amendment. We do see in areas of Europe when we have a lot of nutrients anyway, that a lot of new technologies are under development, and a lot of the Horizon project R&D is focused on those areas in Europe which have, let's say at the moment, excess nutrients. So they are searching for other ways to use and to apply the digestate.
Thank you, Mika, indeed. I will now pass maybe to a question for Jeremy Pound. The first one is, how can we contribute, I guess that the we is about companies or representatives of the sector, to the evaluation of the fertilizer product regulation? And I will bundle in also the second question that is about renewal and whether the criteria within renewal will be considered under the evaluation of the nitrate directive.
Thanks, Julia, and thanks for the participants for their question. So evaluation of a piece of legislation in the Commission is a very strict and transparent process. So we do have call for evidence questionnaire put out on a website. I would encourage you, even as a citizen, to have a look at. It's called Have You Say? And once we have launched the evaluation for FPR, there will be a web page for the evaluation for the full time of the process. There will be a web page for the evaluation of FPR, and there you could see when your input could be possible, and you would, at the end of the consultation, you would have the feedback from the Commission, a summary, and all the input that we have received from other stakeholders. When it comes to the second question and how renewal is going to be part of the evaluation of the nitrate directive, we have also to understand that the evaluation process of a piece of legislation is looking whether at a point in time a piece of legislation is fit for purpose. It's not looking forward in how we can improve the legislation to make it fitter for purpose. It takes stock of, is a piece of legislation fit for purpose? So everything that is around in the environment of a piece of legislation should be considered, whether there are discrepancies between the legislation, its provision, and the environment, including things like science, like a renewal or technical progress, and the renewal project could be considered as is. So renewal is part of the environment that will be analyzed to check whether the nitrate directive is still fit for purpose. How it will be done, I cannot say, because I'm not the one holding the pen. Here, the nitrate directive is in the hands and very capable hands of DG Environment colleagues.
Thank you, Jeremy. So just looking a little future indeed. So you mentioned how in this process of looking how a legislation has been fit for purpose so far. But if we look in perspective, you included in your slide a mention on the Integrated Nutrient Management Action Plan, the INMAP, which is something that as a sector we have been looking forward to as an idea to put together nutrient recycling and a high environmental standard to avoid pollution. So we were wondering whether there are any news in terms of adoption or work within this this project and this strategy that the INMAP is.
So thanks for the question, and I understand it's a very important one for the sector. So the Integrated Nutrient Management Action Plan was a strategy that was announced by the Commission. And actually, it was run at the beginning in parallel to another piece of work undertaken by the Commission about the soil health law. And if you have a look at the soil health law as adopted by the Commission and now in discussion between the co-legislators, the European Parliament and the Council, you would see that it contains items that were sought to be included in the INMAP. So actually, part of the INMAP is already tackled by the proposal of the Commission to have a soil health law. You would see the actions on circular fertilization, on reduction of nutrient loss. So everything that comes from the Green Deal tackling fertilization and issue around fertilization, the first milestone, is in fact in the soil health law and not in the INMAP, because the INMAP is not published yet. So you have to look at both, to look at the soil health law to see how to see the first items that the Commission sought to have in the INMAP, but because the soil health law went first, actually the INMAP is delayed and may not be useful, because you have quite a lot in the soil health law, and depending on how the soil health law will evolve under the negotiation between the co-legislators and all the implementing regulation coming from there, I'm not sure, but I don't have the answer yet today whether there would be an INMAP in a short-term future.
Thank you, Jeremy. It's also good to make the link with the soil health law. We are, of course, following this legislation with great interest and hoping that it will become solid enough as a tool to make sure that good practices are enforced in the various member states to reach decent quality of the soil all over Europe. But I would pass then, since we're touching upon legislation, to Lucille. And one of the first questions that I have here for you refers also to your presentation. So you closed with the necessity of having strong regulatory drivers to support the utilization of digestate-related products and nutrient recycling in general. So what kind of regulatory drivers do you have in mind, and what were you referring to specifically?
Yes, thank you, Julia, for this question. So we have several ideas of regulatory drivers that would be able to incentivize the use of digestate. The first one would be, for instance, to further incentivize it through eco schemes under the Common Agricultural Policy. So these are voluntary measures that can be applied that are rewarded when farmers apply them in their own CAP strategic plan at national level. And the idea there is that when you see, for instance, when you look at all these CAP strategic plans at national level, you have actually only 5 countries that are rewarding the use of digestate as an organic fertilizer. So we think that we could really progress on this, and that maybe during the next CAP we are able to include further the use of digestate and to reward it further. Then another idea that we have is, for instance, in the EU Green Taxonomy. The EU Taxonomy is this classification system that is rewarding and trying to drive investments towards specific sustainable activities in the EU. And there we have an activity on anaerobic digestion of biowaste, for instance. But what we thought is that it could be also interesting to broaden the scope of this activity also to maybe AD of manure, for instance, as it is also leading to a lot of reduction in GHG emissions, for instance. And maybe a last incentive also would be to promote a European nutrient recycling target. So to have, for instance, a percentage of recycled, a minimum target of percentage of recycled nutrients embedded into synthetic fertilizers. That would be also a way to increase the use of digestate as an organic fertilizer.
Thank you, Lucille. I think that we can pass to our last question to Ildiko. I see that the time is a little bit pressing. So regarding the work that you carry out at CertiTrust, do you certify products containing digestate? How many of those? And do you see any growing trends in this specific category of products?
Thank you for the question. Yes, we have already experienced certifying digestate. Actually, there are so many companies who already have a certificate that because of confidential information, I cannot give exact numbers, but I see really big trend in Italy, in Germany, and in France as well. However, I don't see significant increase in Netherlands and Belgium. It's maybe because there are smaller and separated digestate plants, and maybe because in Italy and in Germany they are more concentrated. But we are expecting that, growing will be significant in the next 5 or 10 years.
All right, thanks a lot for taking up this question. I think that considering the timing, we will have to draw to conclusions. I will take the very last question from Alexandra Kohal, which is asking, why is Romania not included into the legislation overview? So Alexandra, this is actually a good opportunity. Please do contact our secretariat. If you do have information that you would like to share on Romania, we are all ears and we'll be happy to include it. Lucille Sever and Chiara Gaffuri, our assistant, did a very intensive job in terms of interviews and research for bringing back elements from the different member states. We were mostly successful in most of the member states. We still have some data gaps and we will be very happy to fill those. So if anybody in the participants feel that there is something missing, we're very happy to increase our understanding and the quality also of the information that we are delivering to our members and to the rest of the interested public. With this, I will have to sadly close the Q&A session. We still have some 30 open questions. We managed to answer 24 today. Please do keep in mind that you can always contact our secretariat on questions regarding the publication that is now online. So with this, as I said, thank you all our speakers today for the interesting presentations, and thanks especially to our host speakers, Jeremy Pant and Iliko Varga, for your time and sharing with us your insight and your competent views. Before we get to a close, please do pencil in your agenda our next appointments. The first one is a very important one. I would say that is a milestone appointment for this year. It's going to be on the 16th of April, and we will be launching a study on the 2040 potential for sustainable biomethane. The 8 authors of the study, Guidehouse, will be presenting their findings directly, and hopefully this will serve also as a solid basis for policy design in the future and to make sure that biogas and biomethane have a solid space into the climate and energy targets towards 2040. The second appointment that I wanted to pencil out will be regarding Fair Play seminar, where partners of the Fair Play projects will talk about circular fertilizers for healthy soil. So again, very timely discussion. The seminar will take place on the 18th of Brussels at Mundo Madu in Brussels, so in person live, and registration are still open for a little bit. And finally, the third appointment, not to forget, is the European Biomethane Week that will be celebrated at the end of October this year with a high-level event on the 23rd and 24th of October. So if you haven't done it yet, please do put it in your calendar, and registrations are open. You can also consult our preliminary program. Getting to a close, thank you all for your participation today. An acknowledgement to the authors and co-authors of the study, in particular, Dr. Gabriella Papa, Marina Pasteris, Ulysses and Cyril, that also helped us out, and to the Fair Play project, who was also a very important step in putting together the data of the information. And thank you again for joining us today. Have a good day, and until next time. Bye-bye.